Can roots be transformed into powers? Well, in this video it will be verified that roots can be transformed into powers with fractional exponents. In the following example, we have the root square of the number 9 that we know that is equal to 3. If we consider our exponent of the number 9 as our unknown x that represents the root square, we will have the following equation. To solve this equation, much like the property of the product and quotient of powers with the same base, we must have the same base in order to have an equality between the exponents. To do this, we power both members to 2. Because it is an equation and doing the same operation on both sides, the equality is maintained. Now, by the property power of a power, we have 9 to the power of 2x on one side and 3 squared on the other side. We have the same base since 3 squared is 9. And this is an equation, so the exponents must also be equal. 9 is the same as being powered to 1, so we have 2x equal to 1. To isolate x, we know that in an equation, everything that passes to the other member passes as the inverse. So, the inverse of multiplying by 2 is dividing by 2. Or we just simply divide both members by 2, and on the first member, 2 divided by 2 is simplified to 1, leading finally to x equals to 1/2. Therefore, we know that 9 to the power of 1/2 is the same as the root square of 9. Now, if we have the fourth root of 9 powered to 3, the same can be made. We already know that the c root of a is equal to a to the power of 1 divided by c. So, in our example, a is equal to 9 to the power of 3 and c is equal to 4. Then we will have the following. By the property power of a power, this will result in 9 to the power of 3/4. We arrive at the conclusion that in this case, if we consider b equal to 3, the exponent of 9, leads finally to the following general expression at the top right corner of our video.